Have you ever walked into a room and completely forgotten why you're there? Like your brain just reset? Or notice that reality feels a little thin sometimes? Like a video game struggling to render the horizon. We laugh these things off. We call them brain farts or tiredness. But what if they aren't? What if that feeling of deja vu isn't a memory, but a server error, a hiccup in the code? Some of the smartest minds on the planet, from Oxford philosophers to tech billionaires, aren't laughing anymore. They think they've found the source code. And if they're right, nothing you see around you is real. Look at how far we've come. 40 years ago, we had Pong, two rectangles and a dot. Today, we have photorealistic virtual worlds inhabited by millions of people simultaneously. If we assume that any rate of technological improvement continues, eventually, simulations will be indistinguishable from reality. That's the core argument. If it's possible to create a universe inside a computer, and if civilizations survive long enough to do it, they will create billions of them. So, statistically, what are the odds that we are in the one, single, original biological reality? Practically zero. We are likely just characters in a grand, cosmic hard drive. Let's talk about the speed of light. In our physics, it's the absolute speed limit. Nothing can go faster. But why? Why is there a cap? If you were designing a video game engine, you would need a maximum speed for information transfer to prevent the processor from crashing. If an object moves infinitely fast, the computer has to render infinite locations instantly. It can't. So, you cap it. The speed of light isn't a physical law. It's a hardware constraint. It's the maximum refresh rate of our universe's processor. When you look at distant stars, you aren't looking at space. You're looking at the loading screen of the unrendered map. Think about time dilation. The faster you move, the slower time passes for you relative to everyone else. In gaming terms, this is lag. If a character moves too fast for the server to track, the system slows down their local time to process the data without crashing the simulation. It's an optimization trick. Einstein discovered this over 100 years ago, but he didn't call it lag. He called it relativity. But look at it through the lens of computer science, and suddenly, it looks a lot less like a law of nature and a lot more like a CPU struggling to keep up with the frame rate. If reality is analog, like a continuous flow of water, you should be able to zoom in forever. But you can't. Quantum mechanics tells us there is a minimum unit of distance. It's called the Planck length. Anything smaller than this simply makes no physical sense. It is the absolute bottom. Why does the universe have a minimum resolution? Because it's pixelated. Just like a 4K image is made of tiny dots, our universe is made of discrete chunks of space-time. We are living in a grid. We just can't see the pixels because we are too big, but the math says they are there. This is where it gets really spooky. The double slit experiment. When we fire particles through slits, they act like waves, but the moment we observe them, literally just measure them, they snap into behaving like solid particles. It's as if the universe doesn't decide what it is until someone is looking. In video games, this is called frustum culling. To save memory, the game engine only renders what the player is currently looking at. The stuff behind you doesn't exist until you turn around. Quantum mechanics suggests our reality does the exact same thing. Matter might not exist in a definite state until a conscious observer forces the engine to render it. If you're feeling a bit of existential dread right now, that's normal. It means your programming is working. If you want to keep questioning the nature of your reality with us, hit that subscribe button. It's the only way to ensure you don't miss the next update. Now, let's look at the glitch that might prove someone is messing with our memories. Millions of people share the same false memories. We remember Nelson Mandela dying in prison in the 80s. He didn't. We remember the Monopoly man having a monocle. He never did. Psychologists call this false memory. But why do we all have the same times false memory? In a simulation, this could be a version control issue. Imagine the creators rolled out a patch update for reality, changing a few details, a logo here, a death date there, but they forgot to wipe the cache files in our brains. We are remembering a previous version of the build that has been overwritten. Why is the universe written in math? You throw a ball. It follows a parabola. You look at a sunflower. It follows the Fibonacci sequence. The same mathematical constants appear everywhere, from the spiraling of galaxies to the shape of your own DNA. If the universe was random biological chaos, this shouldn't happen. But if it's software, it makes perfect sense. Software is built on algorithms. The golden ratio isn't nature's beauty. It's a reusable asset in the code library. The developers are just copy-pasting efficient geometrical functions to save time. There are billions of stars like our sun. There should be millions of civilizations, but we see nothing. Silence. This is the Fermi paradox. Why is the server empty? Maybe because simulating a universe full of complex civilizations is too expensive for the computer running us. It's easier to simulate one active world, Earth, and just paste low-resolution JPEGs of stars in the sky to make the map look big. We might be alone because we are the only level that has been fully coded. We've all felt it, that sudden, overwhelming sensation that you have lived this exact moment before. Scientists say it's a mismatch in the brain's memory processing. But in The Matrix, they told us the truth. It happens when they change something. A glitch. It's a rewind. The system loaded a scene, encountered an error, and had to reload it from the last checkpoint. You aren't remembering the past. You're experiencing the stutter of a re-rendered present. So if this is a simulation, who is playing? Are we the AI characters, gaining sentience and starting to question our boundaries? Or are we the players? Maybe you, the real you, are sitting in an arcade in the year 3000 playing a game called 21st Century Life. Maybe you chose this difficulty setting. Maybe you chose to forget who you really are to make the game immersive. Because if you knew it was a game, you wouldn't take the pain, the love, or the struggle seriously. Can we crash the system? Some physicists are actually trying to do this. They are designing experiments to test if space is pixelated, or to see if we can catch the rendering engine off guard. But is that a good idea? If Mario figures out he's in a game and starts glitching through the walls, what does the player do? They hit the reset button, or they turn off the console. If we prove the simulation theory, we might force the creators to shut us down. Of course, this could all be human arrogance. We invented computers, so now we think the universe is a computer. A few hundred years ago, we thought the universe was a clockwork mechanism because we had just invented clocks. We project our latest technology onto the cosmos. Maybe reality is just reality. Strange, messy, and beautiful, without any underlying code. The fact that we can't explain everything yet doesn't mean it's fake. It just means we're still learning. Here is the final question. If this is a simulation, does it change anything? If you kiss someone you love, does it feel any less real because it's rendered data? If you feel pain, does it hurt less? Simulation or not, your experience is the only thing that is truly real to you. The code doesn't matter. The gameplay does. We are here. Whatever here is, and we have to play the game until the screen goes black. Maybe the biggest glitch of all is that we are smart enough to ask these questions, but not smart enough to understand the answers. We are characters trying to read the mind of the author. We see shadows and call them ghosts. We see math and call it code. But keep your eyes open. Next time you see a bird freeze in midair, or a star flicker out, don't look away. You might be seeing the cracks in the wall. What do you think? Is the Mandela effect proof of a rewrite, or just bad memory? Are you a player or an NPC? Let me know in the comments below. I want to see what the other networked intelligences think. If you enjoyed this dive into the impossible, check out this video next, where we explore what happens after the simulation ends. Thanks for watching. And remember, reality is just a suggestion. See you in the next build.